In this video, we're going to simplify radicals by first using multiplication and then simplify any terms that remain under the radical. For example 1, we have 7 square roots of 3 multiplied by 8 square roots of 15. And you'll notice that 3 is not a perfect square and 15 is not a perfect square. But by using our product rule, we will take terms that are outside of the radicals, like 7 times 8 makes 56, and under the radical, 3 times 15 would give us 45. So another way to write this product is 56 square roots of 45. But we want to make sure that 45 is simplified as much as possible. So factors of 45 would involve square root of 9 multiplied by square root of 5. And this is a good set of factors to use because 9 is a perfect square. We know that if we simplify the square root of 9, we'll have 3. So that makes 3 square roots of 5. And don't forget that it's also being multiplied by 56. So our final answer comes from finding the product of 56 and 3 and multiplying by square root of 5. 56 times 3 makes 168 square roots of 5. So notice we are leaving answers with radical notation, but we have simplified the radical term as much as possible. Now we'll do something similar for example 2. Outside of the radicals, we have 2x multiplied by 5. That would give us 10x. But underneath the radical, numbers 18 times 2 would give us 36. And then I have x to the 5th multiplied by x to the 4th. When we find the product of x to the 5th times x to the 4th, we're actually just adding those exponents. So that would become 10x square roots of 36 x to the power of 9. Our next step is to try to clear any terms possible from the radical. We've got a numerical coefficient and we have a variable base to work with. But you might recognize that the square root of 36 will clear the radical as 6. So 10x already has cleared, multiplied by 6, which is going to be cleared. And then we've got an odd number for the exponent, so we're going to take 9 divided by the index of 2 to get 4 remainder 1. This tells us that the base of x will clear the radical with an exponent of 4, but there will be one base of x remaining under the radical. So now we just have to simplify these terms that have cleared the radical and put them in order. So in terms of numerical coefficients, we've got 10 being multiplied by 6 to give us 60. And then our variable bases, x to the power of 1 is multiplied by x to the power of 4. So that's really x times x to the 4th, or x to the power of 5. Under the radical, we still have our base of x. So our final answer is 60x to the 5th multiplied by the square root of x. In our last example, we have some fractions under the radical. Looking at each radical individually, we can see that 11 is not a perfect square. The denominator of a is not a perfect square either. So it's not helpful to try to simplify that individual factor. So what we're going to do is use the product rule and rewrite these individual radicals as a product written under one radical sign. Our numerators are 11 and 2. So 11 multiplied by 2 gives us 22. denominators, a times b gives us ab. And now if it's possible to simplify anything or clear any terms from the radical, we would look for that. 22 has the factors of 1 times 22 or 2 times 11. None of those factors are perfect squares, so there's nothing more we could do with square root of 22. In the denominator, a is not squared and it has no exponent that's a multiple of 2. B is not squared, it doesn't have any exponent that's a multiple of 2. So we have already simplified the problem by simply multiplying numerators to get square root of 22 over AB.